All right, everybody. We are going to learn about algorithms with arrays. What is an algorithm? I guess I say right there. Process or a set of rules to be followed in calculations or other problem-solving operations, especially by computer. And folks, there's standard algorithms. There's classes in computer science called algorithms where you don't, like, it would be crazy to imagine, oh, I'm going to go and learn about sorting. I got to sort this thing. And I wonder if anyone's ever thought about sorting before. I mean, people have written textbooks and gotten PhDs about sorting. So the point of an algorithm is you don't have to think, wow, how would I do X, Y, Z when people have already figured out how to do it? Not that you can't do things in other ways, but for example, anyway, there's standard and well-worn ways, meaning well-worn, proven, standard and proven ways to work with arrays. And if you can learn them, then you don't have to reinvent the wheel. You don't have to see a problem and go, oh my God, how do I check if there's duplicates in an array? Because we've talked about ways. All right, here's a list of all the different algorithms the College Board wants you to learn. And the underlined ones are ones we're going to do today. So, and we've already done some of them, right? Determine a max or min value in an array. Like you set the variable ahead of time, you go through the whole array, checking everything. You traverse the array, and if you find a new max, you have a new max. Compute a sum and average. We did those. They also want you to be able to do a mode. We'll do that another day. They want you to be able to determine if one element in an array has a particular property. They want you to determine if all elements in an array have a particular property. I mean, they want you to be able to access consecutive pairs in an array. We already did that in Coding Bat on Monday. Or Friday, Monday, I guess. They want you to be able to tell if there's duplicates or not. They want you to be able to count how many elements meet a certain criteria. They want you to be able to shift everything to the right or to the left. Like normally you'd say, get rid of the first thing and move everything over one. Or move the first thing from the beginning to the end and move everything else over. That's surprisingly tricky, but totally doable. They want you to be able to reverse the order of an array. And they want you to be able to swap two elements. So anyway, get ready. Here we go. Checking for duplicates. First of all, let me say this. If an array was sorted, then checking for duplicates would be easier. You could just check every pair and say, hey, if this one is equal to the next one, I found a duplicate, right? But if they're not sorted, what you have to do is pick one, like the first one, and then check if any of the other ones is the same as that first one. So you'll do a for loop inside of a for loop. So check this out. I give you the code here. Here's an array, and I say it's initialized with validated just to keep it vague so you're not stuck on like, oh, there's 12 things. There could be a billion things, okay? Or a million things. In this one, I set up a variable called found dupe, and I set it to false, meaning I have not found a duplicate yet. I'm just starting. Then I'm doing a for loop that starts at the beginning and goes through all the elements. It's going to traverse the whole array. And then check out the inner for loop. The inner for loop starts at the next one. See, it says I plus 1. So if we're doing element I, we're grabbing that. And then we're going to check every other one. And we're just checking, hey, if element I is equal to element J, then we found a duplicate. I hope you can see what's up. Walker. How come you don't what?
How come you start at I plus 1?
Because if you check starting at I, you'll find a duplicate. Itself. They'd be like, hey, are you yourself? I am. I found a duplicate. So that's why you start at the next one. Yeah? I mean, yeah, sure, there's other ways. Yeah. As long as you just don't. You could also put a not statement. If I not equal J, then Don't worry about it. You could also add a if I not equal J right at the front of this. And, if I is not equal to J and they're the same. Then we got a duplicate. Yeah.
Could you use an enhanced for the first one and not normal for the second one?
No, because if you were using it, so the question was, can you use an enhanced for loop for either of these? You can't, because you have to know what index you're on, because you have to be able to start at the next one. So if you did an enhanced for loop on any of them, you would have the value, but not know what index you're at, so you couldn't avoid counting yourself. So anyway, this is one way to do it. I wanted to say, I think I've said this before early in the year, but in code like this, the found dupe variable, we call it a flag variable because you set it to something at the beginning of a process, you do a big process, and then you can check that value at the end. It's like a flag, like you raise a flag on a penalty in football, or, anyway, I don't know. I can't think of a better example. You could be stranded on an island. Somebody's a mile away, and they could say, "Raise the flag if you need food today," and you raise the flag because you need food, and they could see with binoculars, "Hey, they need food. We'll bring them some more food." I don't know why you're living on an island. It's a bad example, but in the same way, we set this thing to false. We did all this work, and if we ever found a duplicate, we set flag the little flag variable to true, and then that way at the end you can tell. There's a different way to do it. If you're doing a method, you don't need a flag variable. You just return true when you find a duplicate. So this is the same code, but put into a method, public static Boolean dupe checker. So you send over an int array, and it does the same thing. Starts at 0, goes all the way through, and then inner loop goes 1, starts at the next one over. And if it's the same, instead of setting the flag variable, just says return true. And then if all the for loops finish and you haven't left the method, then it returns false. That's pretty cool. You have to have a return false at the end. You've probably seen it on where Java says missing return statement. That's what it would say if you didn't. And here's another algorithm. We're reversing the order of an array. And I show you, I think, 3 ways to do this. This is in a method, and we're reversing a string array. So public static string array. This means it's going to return a string array, and it's called reverse array. It receives an array called data. First thing I do, I make a new array called temp. That's the same length as data. And remember, when you create a new array, it's full of nulls. It's not in a string. They're all null. There's nothing in there. And then look, I'm going from 0 to the end, and I'm saying, hey, the new array, temp at 0, is equal to the last element of data. And then it slowly goes through the temp array, and it goes backwards on the original array. And then at the end, I just return temp. I think I have a picture where I show you what it's doing. This is, I said, the magic is on this line where I is going from 0 up to the end of the array. And so we're setting temp 0 to, and the reason this is the last element of data is it's data.length -1. Remember, that's the last element. And then we're minus I. So when I is 0, it is the last element. And then when I is 1, it's the second to the last, and so on. And here's what's happening. Data has, just in this example, these 5 numbers. And so the first line of code sets temp 0 to data 4. So that puts 25 right here. And then when I is 1, it sends temp 1 to 5 minus 1, which is data 3. And I don't do all of them, but I do the animated sound to give you the positive feeling. Here's the same process not using a method. So I have data that I want to reverse. I make a new array called temp, and it's the right length. Has to be the right length. Remember, you can't change the length of an array. And then I is equal to 0 all the way up to the end, and we just reverse it. And then as the last step, I say, you know what? Data is going to equal temp now. Just replacing the whole array with this new array. That effectively reversed the array. And I show you one more version, not using a temporary array. This one's a little trickier. You have to be sure to not go through the whole array with I. I've personally made this mistake. You have to just go halfway through. If you're putting the last one at the first, and then the second to last to the second from the first, and the third, if you go through the whole array, you end up undoing what you just did. Once I gets past halfway, it starts undoing what you did by putting everything back. And so by the end, that's why we do I less than data.length divided by 2. Isn't that funny? I swear, when I first was learning Java, I was doing an online course, and I was like, I know I did this right, And then I started printing out the values to help me debug, and I'm like, what? They were all right, and then they all started going backwards again. And I'm like, oh my gosh. So anyway, this is a little tedious, but let me show you. For this one, we need a temp variable. This is in a way we're doing that swapping thing I was talking about. We're saying, hey, I'm going to have num that I'm just going to use for a minute. I'm going to save data at I, and then I'm replacing data at I. That's like data at 0, the first time through. I'm replacing it with the one from the end. But then since I had it saved, I'm putting it into the end one, because you can't trade places in one command. You need to store one, move one, and then take that one you stored and put it in the other spot. Anyway, you have the code. You can look at it later. Why do you think we would want to access all consecutive pairs of elements? What are some reasons that you guys can think of? I've thought of a few, but because that's the next thing I'm going to show you. Walker. To what? To add a certain value to every element. Oh, yeah, you could add something to every other. If the list was sorted, you could be checking for duplicates, right? Going through, and if two next to each other are the same, then you have found duplicates. I'll just show you. You could check if the data is sorted, right? If it's ascending or descending, you could say, hey, is the current one less than the next one? You could just do that all the way through in int array, and that would tell you if it was sorted or not. You could also check how many times one value followed another value. That might be important for something. All right, so I'm going to show you how to do that. I'm going to show you 2 ways. So in this case, we have an array of doubles. It's got a bunch of numbers in it. And I'm starting at element 1 instead of element 0, going to the end, and I'm checking, hey, is the current one equal to the previous one? So the reason I started at 1 is I knew I was doing an I minus 1 here. If I started at 0 and then tried to do I minus 1, it would crash because you're not allowed to access element -1. So this one just prints the word same if it finds 2 that are the same. This one I did it differently. I started at 0, and I'm doing a +1 here, but you have to add a -1 here if you're going to do that. Otherwise, it'll crash. And I saw like half of you did this sort of thing on the last test. I forget which problem it was for, but a lot of you were starting at 0. We're doing the +1 inside the substring, and some were doing the -1. And both are valid as long as you take care of the right issues. Okay. So now we're going to practice. And I have 6 REPLs I'm going to assign to you. They're A, B, C, D, E, and F. It should keep you busy. I did that rather than have one REPL with a beep ton of things in it, because it's hard to turn in and grade something that big. So we're just doing small ones so that, and they say what they are. Like, hey, in this one, we're checking duplicates, that sort of thing. So I did want to mention that if you're finding arrays challenging, you could spend, you would find some benefit most likely from going to the AP Classroom and watching some of those videos that they give you. There's the teacher who does Unit 6 is great. I mean, I think she's a high school teacher somewhere else back east, and I like her videos, even though she's the one who says data members instead of variable, in a class. But anyway, it's fine. Data member. Sounds fancier for sure. But just the videos are all like under 10 minutes. And if you're like, man, this is freaking me out, worth going in, because this is the end of the new material for this unit. And we are going to have a test next Friday. I'm sorry, it's I know, but it only had 4 sections. The next unit is array lists, which are like arrays, but you can make them bigger or smaller, and they can hold class data. We also have Friday off this week. So this is our last class for the week. I'm going to miss you, but we'll all have a nice weekend. And then Monday and Wednesday, we'll be reviewing. So what I'm saying is if arrays are scary to you and you're having to watch my videos or ask for a lot of help, or you're just not even doing it because you're scared, don't be scared. Go home, make some time, watch some of these videos. They're very helpful. And you could skip it if you're like, okay, I know this part. You don't no, I'm not watching you. You do whatever you need to do, okay? Another great way to practice is to do some of the CodingBat problems over again. And if you just don't log in, CodingBat doesn't remember your answer. So you could just go in and remove your answer. One way to do it is select all and cut your answer. Keep it on the clipboard, and then you can redo it. And if you get stuck, you can always paste your old answer back down below. But I just do it again without logging in when I want practice. So I'm gonna, let's see, stop the video.